Alright guys, I want to show you a trick that you can do with the load testers. Uh, as you know, these load testers, many people have it, and this load tester, they are rated for 150 watts in discharge, and you can do capacity tests in 18650, 21700 batteries. But sometimes you want to test large packs like this one. This one is a 48 volt pack, and discharging 150 watts is very slow, which is about what, 3 amps, 2.5 amps here. And for example, I have this one set to 2.5, right? And I can start discharging, and I'm producing 127 watts right now. Actually, I can go a little bit higher than that. Maybe here, just to show you. The important part is that you don't want to pass the 150 watts that the tester is rated, because you can burn the MOSFET. They use this resistor right now, is heating up. As you can see here, they produce heat, and they're gonna keep going raising that number because it's discharging, right? I'm gonna stop this for a second to explain what I'm gonna do now. So they are rated, as I mentioned, 150 watts and no more than I believe is 10 amps. However, this equipment, it came for be able to add more modules, just like this one. In this one, I have modules added. I have all the way, I don't have I have 4 more, but I have all the way to 3000 watts in discharge. So that one is suitable to test large packs. But this costs money. There is a lot of money that costs all these modules plus install this. However, we have another solution that I find out. If you connect, if you see here, we says we cannot go higher than 2.9 amps, right? So the first step to do the trick is you're gonna go and change and tell like the system that you have a different module. You have more module. I tell already the system that I have, if you notice here, 1200 watts in modules. 1200 watts, it's 8 modules in total, because each one is what, 150 watts each. It's that's the amount right now, right? I don't have that. So if I try to go higher than 150, I will burn this for sure. But I still change that. That's the first step, and then that's the parameter that I have right now. Why? I'm gonna show you the trick. I'm gonna put the data in 0, exit, right? Now we have 0 data. So this module, if you go to those port, the D and the S, you can put an external resistor, which I have here. That one is a large, well, actually there are 2 resistors. There are each one is 6 ohms. So I have that in parallel. So I have a big 3 ohm resistor. Why? This one, each one is rated to 500 watts. So I have 1000 watts available in this one. I have another. You need to play with the ohms. I have this set right now for this kind of batteries discharging, and now this is what you can do, right? Here's the important part. I know that I can discharge by the math about 16 amps from these with these resistors, plus I can add what, 2.9. So let's see, 16 plus 2.9. Let's see. I can tell the system that I want to charge 16 more, right? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 16 plus 2 more. So I can go up to, let's say that I want to discharge 20. I'm not gonna be able to go there, but no, actually I have to go lower. Let's see, to be safe, I'm gonna say 18 amps. I'm not gonna start this yet. Why? because this one is gonna try to pull all that power if I try now. So I ain't gonna burn this equipment now. What I'm gonna do is connect that resistor. See, I have one cable over there. I'm gonna plug the other one here. That's gonna make a big spark because it's 18 volts. I mean 52 volts, so it's higher. Now look the numbers. And right now the equipment is off, but as soon as I connect that, it's gonna start pulling power. Now look at this. It's gonna make a big spark, and this is gonna start heating up very quickly. Let me put this fan here. Now right now I'm pulling, look at that, 811 watts, and it's pulling 16 amps, and the equipment is off. I can turn this on, and then it's gonna pull the rest. See? And now I can discharge quickly this battery out of this equipment. So if we check, this equipment is gonna heat up a little bit only, because I'm taking only about 2 amps. It's taking like about 100 watts only. So, but this one is gonna heat it up a lot. That's why I have that fan. That one is taking over 800 watts right now, and it's gonna keep going, raising that temperature. So right now I don't have the correct setup to cool down this resistor, but because I'm making just this as a test to show you, so I'm not gonna leave this too long. If you see, it's gonna keep going, raising and raising. This equipment is cold. Now there are a few things that I have to mention that you have to do. See, it's working. 883 watts right now. And this equipment is fine. Now, very important, I need to disconnect as soon as I finish. You know, right now this is super hot. I need to disconnect first. I mean, turn off first this equipment before disconnect this one. Why? Because if I disconnect this first, this equipment is gonna try to do the 18 amps, which is impossible to do, and I'm gonna blow that MOSFET. So in order to, I have to turn it off first. Now I disable the MOSFET. If you see, it keep going pulling. So I have to disconnect this manually. So see the big spark? This is really hot right now. Really hot. This is not. So this is like normal. So in order to do your test, you need to play with the amount of ohms that you need the you don't need that big resistor like this. You can do the test with lower resistors with 200 watts, 100 watts. You don't have to pull that amount of amps. I mean, you can go with lower. The point is that you can raise the power of this equipment by adding external resistors on those ports. You can use that one. You can use from this side or the top side. It doesn't matter. So in that way, you can increase the power that you can pull. But you have to be careful and follow what I'm telling you. Otherwise, you will blow the MOSFET from this equipment. All right. I hope that give you some light and you know, options that exist to do this. Okay. All right.